Hello everyone, I hope you all are doing well. So in this video we will go over the activities for Unit 8. There are two activities. The first one is selection activity and the second one is repetition activity. I will not complete the second activity fully because there is a question in that activity which depends on another topic from Unit 8, which is not yet covered. So I'll stop at, I think, the fifth question in the repetition activities. Anyway, so these two activities cover the if statements, which are the selection statements, and the loops. There are different kinds of loops. We studied about for loop and while loop and until loop, and those are the concepts we are going to practice. So let's start. So for the first activity, for selection activity here, there is activity 0, and you're supposed to create a bash script called template.sh that contains the standard good comments for your scripts. You can choose to do this on your own, but I'll show you how you should be how you should be creating this script. So the first thing is you will create a directory for Unit 8. So mkdir 8 unit, and then cd 8 unit. I think I will just change the settings here to increase the font size. Okay, I think this is better. So now I am in the Unit 8 directory. Here you're supposed to create vi template.sh, and then here you just copy all of this, press insert, and then right click, and it pastes everything there. Okay, this is, I think, for all your scripts you're supposed to use this template. So you'll just create a copy of this script and then use it for your new scripts, and that's about it for this activity. So escape, I'll just save this, and yeah, and you can also do the chmod plus x template.sh, so that when you copy the template, the execute permission will be there already. Okay, so the first activity is you're supposed to create a bash script password.sh that will ask the user to enter a password to gain access to, I think this is A, to gain access to a system. The password is a number, and these are the steps you need to follow. So the first thing I would do is I would create a copy of template and name it password.sh. Okay, and then if you do ls, you will see password.sh already has the execute permission. So anyway, you will do vi password.sh, and then everything is written for you. All you need to change is probably, I don't recommend, to be honest, to basically write here, what do you call it, the name of the script, because sometimes you can change the name and then the information here would be incorrect. But I recommend writing your name as the author. Okay, and then the purpose of this script is to, okay, I don't know what's happening here. So the purpose of this script is to basically, what's happening? Okay, anyway, the purpose of this script is to ask user to enter a password, gain access to a system. Okay, that's the purpose. And then define your variables here. So the first thing that they want you to do is to basically, what's it called? Store the password 1000 in your bash script. How do you store something? Whenever the question says store this value, you need to create a variable. How do you create a variable? You're supposed to give it a name. So here I will name it password is equal to, just remember there are no spaces, okay? Password equal to 1000. That is your variable, okay? That is that is the answer for A, the step A. Then you're supposed to ask the user to enter a number using the echo statement. So when you're supposed to ask something from the user, you're supposed to let the user know what you want. So in this case, we want the user to enter a password, right? So we need to tell the user, please enter the password. So that is what you will write here on the next line. Again, it's up to you if you want to keep these comments, the ones that are here, it's up to you. But what we can do is we can create all the variables here. We can write the code, the actual code. Is it code? Whatever, the actual commands here on the second, like after beginning of main. And then later on when we study about functions, we can write them after this comment. Anyway, so I'll write the code here. Echo, enter your password, let's say. Okay, so this will be displayed to the user, and then the user knows what they're providing you. If you don't write this echo statement, the user doesn't know what to enter. It will just it will try to read something, but the user is not aware of what you exactly want. So it's always a practice that you need to tell user what input you're expecting. So in this case, you're telling them, please enter your password. Then the step C is use the read statement to read in and store user's entry. Whenever the question says ask, I mean, in this question, they have given you the steps. But let's say they did not, there's a question which is similar to this, but they don't give you the steps that need to be written, like the code that needs to be written. So in those cases, just remember whenever the question says ask the user or prompt the user or read from the user, you're supposed to do two things. You're supposed to echo. Oh, what? You're supposed to echo, and then you're supposed to read from the user. So two statements. One is echo. You tell the user what you want, and then read. So whatever the user is going to provide me, I will store it in user password, which is another variable. If I use the same variable password here, what will happen is this value will be gone. It will, the system will remove the previous value, which is 1000, and replace it with the value that the user gave, right? When the read command was executed, whatever value the user gave, that will be stored in password. So then it is overwritten and we don't know what the correct password is, because in our case password is equal to 1000 is actually the correct password, and that's what we're storing in the password variable here. But we need another password which is basically the password that the user gave us so that we can match the two together. Okay, so anyway, you will read read the password from user, and then you're supposed to use an if statement to compare the user's entry to the stored password. If they match, issue a message to the user to say that they are granted access to the system. You can use the -EQ operator in your comparison. Now, you're supposed to check. Whenever there is a situation in code where you need to check something, you will use if statements. Okay? Check or compare, whatever that is. So here, if space bracket, space, and then your condition. So in this case, I'm going to check if this password is the same as the password that the user gave us. If they are the same, then you grant the access. Otherwise, don't grant. Okay, so in this case, you will check if password. Now, because we need to get the value that is stored in password, we have to use dollar and then the name of the variable. And then you use the EQ operator, which is nothing but equal to. So you're checking if this variable, the value in this variable is the same as the value in user password. So again, user password. Okay. Then echo, you are granted access to the system. You can write it with quotation, the double quotations, or without it, it's completely fine. And then fi at the end. So that's the structure. You write the if statement, there has to be a space after the if statement, a bracket, and then another space, and then your condition also needs to have spaces, and then space at the end, and then finally the bracket. And once you've written the condition, then after that you need to write the word then, and then whatever you need to do in that situation, and it ends with fi. Okay, that's your basic structure of writing a selection or an if statement. So that's done. Escape wq, and then if you now run, what was the name, password .sh. See, now it's telling me enter your password. It's waiting for me to enter here, but because I can see the message enter your password, I know what to give. If there was no echo, I wouldn't know what to enter there, right? So that is important. Every time the question says ask, you need to do an echo and then read from the user. So in this case, if I enter 1000, it should say you are granted access to the system. Now, in the case when I don't enter 1000, it's doing nothing, right? As a user, I don't know what happened. So it is the best practice to let the user know that something was not successful. Just like when you try to log into your Instagram account and the password is not correct, the app will let you know that your password or your username is incorrect. Please try again. So for that situation, we have activity 2 here. So extend activity 1 so that if the user enters an incorrect password, you notify them that they have done so. Add an else block to the existing if statement. So I would go back to my script, and then after the situation where it says the passwords are equal, we're going to say if the passwords were not equal, which is using the else statement, you have to let the user know password incorrect. Please try again. So what happens is if this condition is correct, this statement is executed and the else statement is rejected or skipped. All right. But if this situation or if this condition was incorrect, meaning the password that is stored is not the same as the password that the user gave you, then you're supposed to then this statement will be rejected or skipped, and the statement that is present in the else block will be executed. So in that case, the system will print password incorrect, please try again. So again, I will save this, and if I run it again, it will tell me password incorrect, please try again. So that's activity 2. Now activity 3, create a bash script tell number.sh that will read in an integer number from the user. The script should tell the user whether they entered 0, a negative number, or a positive number. So again, cp template to tell number.sh. I will copy the template and create a new script, and then open the editor. Here again, you can do whatever changes you want. I'll just show you the code here. So again, see how it says read from the user and integer. Remember what I said earlier? When the question says read, you need to do two things: echo and let the user know what you're reading from them, and then read it and store it in a variable. So in this case, I don't know if I need a variable. I don't need a variable here, I think. I mean, I don't need to initialize a variable here, but here on the beginning of main, I will just echo please or enter a number and an integer number. So that's my echo. That's the first thing. And the second thing is read, and maybe I'll just name it number. So read number. So it will store whatever value the user gives you in a variable called number. Now your job is to figure out if this number that the user gave you is either 0 or a positive number or a negative number. You can do it the way you want. I will show you the way I think is correct. I will just follow this order. So first I will check if it's greater than as stated in the Word document. Then I will check if it is less than, and then finally I can use the else for that. I will show you that now. So the first statement would be if. Again, remember, after if there is a space, bracket space, number. Again, I made a mistake. When you write a variable name in an if condition or if anywhere else, you need to, when you're trying to access the value of a variable, you're going to use the $sign, and then here it would be $number is greater than 0. If a number is greater than 0, then it's obviously a positive number. So I will just write it like this. This is a positive number. Now there's another condition, right? If there were only two conditions, in the sense that if I had to check if it's a positive number or if it's a negative number, then I can use else after this. But here we have three conditions. So anytime you have more than two conditions, you're supposed to use elif, like ELIF, which is nothing but else if. So else if is the same as if, but it's like the second. It's like not the first if statement. What I mean by that is this statement will be executed first, and then if that was not correct, only then it will move to the next one. So anyway, elif, and then the same thing, number is, let's say, less than 0. Then again, when you're using elif, it's the same as if. So that means there has to be a condition here, and then you need to also write the word then. So if it is less than 0, then obviously it's a negative number. Okay. Otherwise, now when you're using else, or when you're writing else block, you don't have to write a condition next to it or the word then. You don't need to write anything, just else and whatever needs to be done in that case. So else echo this, you entered 0, and then to close the if, you will write fi. Now, why did we use else and not else if to check the equal to part? It's because that's logical, in the sense that if a number is greater than 0, then this statement will be printed and everything else is skipped. Okay. But if it was not greater than 0, then it will move to the next statement. It will check, okay, if it's not greater than 0, but is it less than 0 now? If it is less than 0, then this statement is executed and everything else is skipped. But if it was not even less than 0, then it's a common thing. Like, it's common sense that if it's not greater than 0 and it's not less than 0, then obviously the number is 0. So in that case, you just use else, because you know that's the only solution or the only situation that's left. So anything that's the last situation that's left, you can put it in the else block. So that's how this will work. You just save that here, and then tell number, let's say 20. This is a positive number. Run it again, minus 20. This is a negative number. And then run it again, 0. Okay? And then it says you entered 0. So that's how it's working. That's how you would do this activity. Then for the next one, you're supposed to create a script, test underscore arg dot sh, and then that will tell the user whether a file name passed to a script exists or not. So the first kind of question that I told you about is the one that says read from the user or ask the user or prompt the user. In that case, I told you you need to echo, let the user know what you're asking, what you're expecting, what input you're expecting from them, and then read and store in a variable. But there's another way, which is another kind of a question where they will say, do something with something that is passed to the script. Now, when it says passed to the script, they mean arguments. Okay, and in class we've gone through this, but arguments are passed, like when you run the script, just like here, this is an example of running this script here. So you write dot slash and then name of the script, space, whatever argument you want to pass. This is like passing data to the script. So they're saying a file name will be passed to the script. You need to check if this file exists or not. Okay, so how do we do that? First of all, copy from template and name it test arg.sh, vi test. Okay, again, change whatever you want from the comments. I will skip that. Now here, I don't need a variable name, I think. Here, we already have the data that we need to check, which is being passed from the script. Which is being passed to the script as an argument. So here we don't need to echo. We don't need to read from the user is what I mean. So the first thing you will do is you will just check if, and again space, bracket, and then if minus e. Minus e stands for exist. Okay, this means whatever file name you're providing to this condition, it will check if that file exists. Okay, so minus e for exist, and then the file name. How do we get the file name? It is an argument. It is passed to the script. So when you're running the script, what happens is this thing, the first, whatever the name of the script is considered $0. Okay, anything after that, all the arguments are considered as they are numbered. So meaning this, the first argument will be considered $1, the second argument will be considered $2, the third argument will be considered $3. So our file name is basically the first argument that is passed, or the first data that is passed to the file. So in order to get that, in order to fetch that, you can just write $1 and then close that. Then, so if it exists, if this was true, meaning the file exists. So in this case, we will print file file exists. Or you can be very creative and also add the file name. $1 file exists. And then otherwise, we print $1 file does not exist. And then close the if. Okay. That's it. So save that and then run test arguments. What file name? Okay, tell number.sh should exist because this is the activity that I created previously. If I just change something here, it should say it doesn't exist. Okay, you can test it out with the files that you have. Now, the file name to be checked should be obtained from the arguments. I explained that. Test if the file exists. If the file exists, display file exists. Oh, we had to display it like, oh, it's up to you. You can display it like that, or you can display it with the file name. And then if it does not exist, display file does not exist. And we already used -e to check if the file exists. So that's, what's this one? Fourth. That's the fourth activity. Now for the fifth activity, you're supposed to copy the script that you just created. So cp test and then test dir and then sh and modify it so that it checks the, where is it? I forgot the line. Okay, modify it. So modify it to also test directory status. If the file entered as an argument exists, then test to check if it is a directory or a file. The script should print on the screen the word file or directory as appropriate. Improve the script to check that there is only one argument passed. Okay. I will go step by step. So we now have the fact. So here we're checking if it exists, then file exists. Okay. Otherwise, we're saying file does not exist. Now the question says also check if the file exists. Check if it is a directory or an actual file. Okay. And print accordingly. So if it is a directory name, then print it's a directory. If it's a file name, then print it's a file. So either you can here, okay, if now, how do I explain this? If the file exists, only then we need to check, right? So here, what you can do is you will check if the file exists and then you will print the file exists, right? You're not supposed to do that. Now, if it exists, you have to check again. So there is another if statement so you have this one whole if statement here, right? You will add another if statement within this if statement. So I will check if -b $1, then echo directory. So -d checks if the name is for a if the file name that is provided, if it's a directory or not. If it's not a directory, then you have to check it is a file. So -f $1 and then echo file. Okay, and then do we do else? Okay, that's that's a question. Do we do else? Let's leave else. Okay, and let's see if this will work. So I will go back and I will test it. First of all, clear this and then test directory, and then I will pass 8 unit. I think we need the else statement, but I am not sure what we will print in the else statement. Anyway, go back to, where is it? So here we're checking for file And what can we do here? Oh, the problem is not with else. The problem is the fact that I forgot to write then. I hope this works. Okay, unit 8 file does not exist. Oh, because I am in the same directory. Okay, let's make mkdir test, and then test is a directory. Okay, and then if I write test arg, it's a file, which is correct. If I just change this, it does not exist. Perfect. The reason it didn't work the first time is because I was using the same directory name in which I was. So that was the issue there. Anyway, so we fixed that. Now let's go back to the file. We need to do one more thing. We need to improve the script to check that there is only one and one argument used. So the user should only send one argument. And they have given you the hint here, which says use the $# special symbol that gives the number of arguments, and the is equal test, which is minus EQ, or not equal test. Okay, and then if zero or more than one arguments are found, the error message will be in the form to use the script correctly, type, okay, file, comment your program. Okay, so here, before doing anything, what you need to do is check if the correct number of arguments are passed to the script. Okay, so the first check would be if if $#, which means the number of arguments, is equal to, or let's say is not equal to 1, then echo, and then this thing here, I will just copy it and paste it here, and then exit 1. Exit 1 means just close the script, just leave, return back, don't execute anything. So whenever it finds exit, it will not run any of this code here. So after that, you just close that if statement. So now, if we go back and run this without any argument, it should give us the error message. If we run it with 2 arguments, it should give us the error message, but with 1, it will work. Okay, so that's how you will do it. That's activity 5, I think. Now, the last one, not the last one, there's one more. And this is something I want to explain as well from the PowerPoint. But now you're supposed to create a script, check user. So again, copy template and then check user.sh. vi check user.sh, change whatever you want. And then the first thing you need, okay, that will test if a given user exists in the etc passwd file. Now I don't know if they're reading. Okay, they're not reading anything from the user. They're saying that you should create a variable name and give it a value, the username you want to search. So I will name it, let's say, user equal to, and my name. Let's say I'm trying to search my account. Then you're supposed to find the name in the etc passwd file. Now, if you remember from the content that we studied before the exam, before the midterm, the way to check if something exists in a file, if a text or a piece of text exists in a file, you need to use the grep command. So grep, and then the value that you're searching. So $user, and in quotations because it is text. So grep this text, and basically it should start, right? So I will put the symbol for referring or signifying that the line in the file should start with the user with the username that I'm providing. Search this in /etc/passwd file. Okay, search this in this file and send it to a temporary file. Why am I sending it to a temporary file? Because I need to check if something was found in the etc passwd file. So let's say if in this file, passwd file, if my username exists, then that will be written to the temp file here, right? But if nothing was found, then this temp file doesn't exist, right? The temp file is only created when the, what's it called? When something was found in the passwd file, which was redirected to the temp file. Otherwise, that file is empty. So that is what we will use to check if something was found in the passwd file. Because if the file is empty, so if exists temp, then echo user found, or let's say just write it like this, found. Okay, user account found. Okay, otherwise user account does not exist, and then close if. So if something was found, it is sent to the temp file. If nothing is found, there is no temp file. And that is what you're checking. If the temp file exists, then because this temp file only exists when the script is executed, right? If nothing was added to that file, then that means nothing was found from the grep command. So if the file exists, that means the user account was found, otherwise it's not found. And before, okay, we had to follow these steps. So you need to redirect the output to a temp file. If the name is found, print a message. Okay, if the name is not found, print error message. We did that. And then you need to delete any temp file. So the temp file that we created here, we need to remove it. rm temp. Done with that. And then check user. So my account was found. Now if I go back and change this. Oh, I forgot that there is quotation, but anyway, it still found my account. Okay, anyway, let's try it again. Because I think it's taking part of the word. Anyway, I will go back and first of all add quotations because it is text, and then change okay, I think it's just taking part of the text. It's not taking the whole word. But anyway, if I try to create an account, if I try to use an account, I don't know why for everything it is showing account found. Oh, there's a mistake I made. We're not checking here if it exists or not, because I think in either case it is created, the temp file is created, but in the case when no account is found, the size is 0. My bad. I forgot about that. So here you just need to change it to -s. That means it exists and the size is greater than 0. Because I think when you do the grep statement, if it is found, the temp file is created. If it is not found, it is still created. But the only difference is if the account is found, the size of the temp file will be greater. I mean, it won't be 0, which means that the file will not be empty. So now I think it should work. Yeah, not found. Does not exist. So that's what's it called? Activity 6. But there are issues with this approach. The problem here is that you are saving uh, what's it called? Confidential information in a temporary file. And for some reason, if your script, let's say, crashes somewhere here, then you never removed the temp file. So the temp file will already be stored on the system. So for example, if let me show it to you, I think it will make more sense. So if I don't add this statement and I run the script, oh, 1 second. If I run the script and then I do ls -l, you will see there's a temp file that was created by the script. So in cases when the script crashes in the middle and it doesn't finish fully, then in those cases, the temp file is never deleted. It will still stay on the system. And that the grep command is actually adding sensitive information. So for example, if you do cat temp, you will see what happened. There's nothing inside. Oh, because that account doesn't exist. So for example, if the account exists here, where is, for example, if this was my account, if this was my account and I run it and then I do cat temp, now it has my information there, which is not, I don't think it's a good way. It is like information that is, maybe some departments don't need access to that, and if they have, something can happen, some security issue can happen. So in that case, what you do is you don't, what's it called? You don't, for sensitive information, you don't add it to temporary files. So first of all, I will just go back and remove the comment from here before I forget to do it. Okay, and then I will show you the actual way of doing it, or the alternative way of fixing this code, of fixing this issue. So here, I think it is this one. No, this one. Okay, yes. So here you're saving then the account name in a variable, and then you're using the grep command. This is the solution we used. Now, what you're supposed to do is you're supposed to use the grep command directly in the if statement. Before we wrote it above the if statement and then we were checking the size of the file. Here, what you're supposed to do is you grep the account name from passwd file, and then you send it to something called dev null. Now dev null, just think of it like this. It's like a place where any output that is generated by a script can securely be discarded. So it's like a shredder, if you can relate to it. Like you have paper, for example, you have important papers or papers that have confidential information, and you pass it through a shredder so nobody can see the information, or nobody can have access to that information. So it's kind of like a shredder. Okay, so dev null is basically to discard output generated in a script file securely so that nobody can ever have access to it. And then this part where it says, I don't know if you can see the mouse, but this part, the part where it says 2 and then redirect and 1, ampersand 1. What this does is the grep command only works. Okay, before that, let me explain it. I'll just open the presentation mode. Why? Why? Okay, I want this to be extracted to this PC, not this PC, desktop. Okay, and then I will open the file from there so I can edit it and I can show it to you because that's important for you to know. I swear I sent it to desktop. Where did it go? Extract to, oh, okay. Desktop, unit 8. Okay, here it is. Are you serious? Where are the other files? Anyway, maybe that's the only thing I selected. So here, let's quickly open it. Okay, if you remember from the previous from the previous units, there are 3 ways of communicating, as in 3 communication channels. There is input, if I can write it here. So it's very difficult. Please bear with me. But input, I will just write in for that. And there is output. Yeah, of course, everything has to break at this point. Anyway, error, and the last one is error. Standard input, standard output, and then standard error. I will just write ER, and then one more R. Okay. I can't believe this is happening. Anyway, so input is basically 0. Sorry for that. Output is basically 1. And error is 2. Okay. All of these communication, the standard input, output, and error, they have specific numbers, 0, 1, and 2. This statement, when you use grep and all of this, and when you redirect it, the redirection only works when the output from here, which is whatever this command does, is 1. It's basically, because it's output redirection, the statement only works when there's an output. What that means is whenever this statement here generates an error, this output direction never works. Okay, that means the whole statement will not work if there's an error and it would just crash. What this part means is kind of like forcing it. You're saying, please, if there's an error, which is the 2, which is represented, the standard error is represented by 2. So you're saying, please, if there's an error, can you please convert it to a standard input? Because 1 stands for out. Can you please convert it to standard output? Because 1 stands for standard output. And when the error is changed to the standard output, it would then successfully execute the information. In short, the whole concept is that if there's an error, just change it to a standard output so that the command never crashes. Okay, that's the whole concept. The reason I showed it to you in so much depth is maybe you need it for your theory, but that's the whole concept. You grep, you don't grep it before the if statement, you do the grep statement in the if in the if statement. And then you redirect it to something called dev null, which is nothing but like a shredder, so that nobody else can see it. Nobody else can see the output that you're generating from the commands here in the script. And in case this command, the grep command, gives an error, please change it to a standard output so that no error ever happens in that command. I hope that's clear. That's the best way to remember it. Dev null is like a shredder, and if there's an error while you're sending anything to, or while you're running any command, if there's an error, just change it to standard output so the error never happens. Okay, and then exit 1 is just to exit from the script. Okay, that is done. Now I'm sure this is going to, okay. I knew this will happen, but anyway. Okay, so this goes here and then selection. So that is the alternative way of doing activity 6. I have explained it to you. Now for activity 7, this was homework. You should have done it. If you don't know the answers, you can ask me, because I really want to move to the repetition activity, and this is getting too long. So just do this on your own. If you need the correct answer, just email me. I will send you the correct answer for this one. Okay, so we're done with the first one, finally. And then let's go to repetition. Okay, so here, the first repetition is nothing but loops. Okay, so the first thing here I would just do is move to Unit 8 lab. And then start with the first activity after I change the font size. I just feel like this video is all over the place. Okay, anyway, so the first activity here, what should I, okay, anyway, CP, copy the template again. There is a template, okay, template, and I will name it, what should I name it? R1, maybe R1.sh, repetition 1, that's what I'm thinking. Anyway, we are R1, and then change whatever you want to change, and then I'll just write the code here. So you need to create a bash script that will print out the text I love Linux 5 times. You should use a for loop. There are 2 for loops, one is counter and one is range. You can use whatever you want because it doesn't specify which one. I'll show you both. So the first one is for, and then the counter, which is, let's say, I, or you can even name it counter. And then in, which is this one, is used as a range or a list. Okay, so in 1 to 5, do, and then done. And then within do and done, just echo I love Linux. Okay, what happens is the counter here will start at 1, okay, so and end at 5. So it will start at 1 and increment 1 at a time and end at 5. So it will, when it's 1, it will print Linux, I love Linux once. And then when it changes to 2, it will print another time, I love Linux, 3 another time, 4 another time, and 5 will be the last repetition or rotation. So that is the first way. I will now run this, and you can see it displayed I love Linux 5 times. Now the second way of doing this is the one that has the counter, the for loop that can use a counter. So you just change this part here. You will say, you will put 2 brackets, two round brackets, and then you will specify the starting position for the counter. So let's say we're using counter is equal to 1 semicolon, then the condition counter should be less than or equal to 5, or you can even say less than 6. So it will stop at 5, and then semicolon plus plus counter. Plus plus counter increments the number 1. Okay, so in the beginning, the counter is 1. The value for counter is 1. It will check if counter is less than 6. So 1 is less than 6, obviously. Then it will do whatever is mentioned in the loop. Then it will go back here and it will increment with 1. So now counter changes from 1 to 2. Then it will check again. Is 2 less than 6? Yes, it is less than 6. So it will print again, I love Linux, and then go back, increment. 2 becomes 3. 3 is less than 6. Print again, increment again. It becomes 4. 4 is less than 6. Print again. Go back, change it to 5. 5 is less than 6. True. Print it again. And then go back and change it to 6. Now, the minute the counter becomes 6, this condition becomes false, and then you can just exit the loop. Okay, so when it becomes 6, then I love Linux is not printed. So you will notice that the counter is equal to 1. The first statement only gets executed once, and then the whole loop is between the condition, the block, and then the increment. So it checks, executes, increment, check, execute, increment. It keeps doing that until the condition becomes false. So this is the counter loop. It will do the same thing. If you run it, it will print it 5 times. So that's first. Now create a bash script that will loop 5 times, each time printing out the loop counter, and you should use a for loop for this. So here, how about I just copy R1 to R2.sh. So vir2. Okay, here instead of printing echo, you just print you just print dollar counter. So it will print the value of counter every time. So if we run this, 1, 2, 3, 4, 5. You can do the same with the other loop as well. The only thing that will change is the first, the condition, the statement that you write in the for condition, for statement. Okay, so that is done. The third one, you should create a bash script. Actually, I feel bad. Maybe I should explain more. The same thing is happening. You write the code the same way. It's just that you, instead of echoing the text, you just replace it with counter. And here, the other way would be for counter in 1 to 5, do echo counter, and then done. So now if I run this, it will print the first one is from the first loop, and the second part is from the second loop. So that's how you will do activity 2. Activity 3, create a bash script that will loop 5 times, each time printing out the loop counter. Use a while loop for this. So this one, not this one, where is it? Okay. R3, vir3. Okay. Here, again, change all the comments. And once you're done with that, you are supposed to loop through 5 times, printing the counter, but using the while loop. With the while loop, the counter is written outside. So counter is equal to 1, let's say. Then while, and the condition that you write with the while loop is the same as the condition you will write with the if statement. So while dollar counter is less than, I think, okay, less than 6, do echo counter, and done. Now I want to show you something interesting here. If you do it like this, which is similar to what you would do for a for loop, this will happen. So if I run this R3, see, it's always printing 1 for me, and I've never been able to see the prompt. This means this is an infinite loop, which means you've made a mistake. It an infinite loop means it will run forever until you stop it. So we need to stop it, and the way to stop this is you press Control and C. You press Control and C, and it stops, and then you go back and fix your error. So here we started with counter 1. We're checking if counter is less than 6, and then we're echoing counter. But there's no way, no place where we're incrementing the counter. It's always 1. That's the problem. So in order to fix that, you need to increment the counter here. And to do that in a while loop, you should do it this way. 2 brackets, dollar counter. No, when you're using the 2 brackets, don't use the dollar. It's just counter plus plus and then 2 brackets. WQ, run it again, and now it's 1, 2, 3, 4, 5. Because now the counter is incrementing every time you're looping through it. Okay, that's activity 3. Then for activity 4, create a script list 1 dot okay. So cp r4 vi r4, and then here, okay, you're supposed to create a script that uses a for loop to display on screen all the arguments of the script. Hint, $* is the special argument. Special argument allows you to access all the command line arguments, and then use the command base name to give the name. Okay, so basically when you run the script, it will look something like this. There are 4 arguments here. You need to display all of these 4 arguments and the name of the script. So when you run this command, it will say this script is called and then the name of the script. And then on the next line, it will say the arguments are and all the arguments on separated lines. So in order to do this, now the first thing you need to do is basically print the script name. So you just do echo this script is called. That's the first line, and then the second line has the name of the script. How do we get the name of the script? We know that the name of the script is basically $0. Then after that you have the arguments, which is $1, $2, $3, and then $4. So in order to display the name of the script, you can just write echo dollar base name and then $0. Okay, you can write it like this. You need to write dollar bracket base name and then $0, which gives you the name of the script. That is done. Now for loop is needed to display all the arguments. Before the for loop, you will echo the arguments are. Why are we writing it outside the loop? Because if you write this inside the loop, it will print every time you are going to loop. Okay, so after this, you will write your for loop. You will say for for argument in dollar star, if I'm not wrong. Yeah, for argument in dollar star, done, sorry, do, and then done, and then just echo argument. Let's see. I can't be always correct, so let's try. If it's R4, oh, we didn't send any argument, but the first part worked correctly. This script is called R4SH, which is correct. But here, let's say I send it my full name. Okay, I know what I did. I have to put dollar argument because you're getting the value. If you just write arg, it will consider it as text. So go back, fix it. Now it's working properly. So all the arguments are displayed on the separate lines, and then you're also displaying the name of the file, which is correct. Then you're supposed to create a script that does the same as list arguments one but uses a for loop. Use the shift command to reduce a parameter by one, move to the left. Okay, so here we just copy 4b. I think I can name it 4b r4. Okay, bi r4b. All of that is correct, but this needs to change to while loop. So while how was this is not equal to, okay, while $h is not equal to 0. I will explain this now. And you just print $1 and shift. Okay, what is happening here is, wait, I want to test this first. If this works, then I will explain it. Okay, it's working. Correct. Okay. So what's happening here is you're saying that the $hash should not be equal to 0, which means the number of arguments should not be equal to 0. Why are we saying that? We're saying, okay, we're starting, we take all the arguments. When we run the script, we take all the arguments, the 3 arguments that I just showed you in the example, and we have 3 at the moment. So when you take $hash, it will say it's 3 because it has 3 arguments, which means it's not equal to 0, correct? In that case, print the first argument. Okay, now the first argument would be the first thing that you sent, which is $1. The shift command, what it does is it removes the argument that was currently used and moves to the next argument. So the second argument in the, for example, here, you're running this command, right? And it has 4 arguments: Phil, Trevor, Robert, and David. The first time, the number of arguments is 4, which is not equal to 0. In that case, print $1, which is Phil. Okay. Then it's saying shift, which means go to the next one. It's basically reducing the numbers. It's basically getting rid of Phil and it's moving Trevor to left, Robert to left, and David to left. So it's basically getting rid of this statement as the first parameter, and it's moving Trevor to, it's moving all the parameters, sorry, all the arguments to the left. In that case, let's enable editing, to be honest, so it makes sense. Okay, in the beginning, you have Phil, Trevor, Robert, and David. So there are 4 arguments. So in that case, 4 is not equal to 0, correct. Echo $1, which is Phil, right? Done. We print Phil, and then we reach the statement shift. Now in this case, what happens is it gets rid of Phil. Gets rid of Phil. Now you only have 3 arguments. Okay. Again, you go back here, you check in the while statement, the number of arguments is 3 and it's still not equal to 0. So you will echo $1. In this case now, $1 is Trevor. So it will print Trevor and it will shift again, meaning get rid of Trevor and shift everything to the left. So now you have 2 arguments. You have Robert and David. So the statement is still true. In this case, you will echo $1, which in this case now is Robert. So it will print Robert and then shift again. So this will be removed and David will be shifted. Again, $hash is still one, I mean, the value is 1, it is not equal to 0. So again, you will echo $1, which is now in this case David, and then shift again, which makes 0 parameter, 0 argument. Okay. Now this condition becomes false, and then you leave the loop. That is what is happening basically. So with shift, it's removing the first argument and shifting all the arguments to the left. All the other arguments to the left. Okay. That is done. And then just write comments. I hate comments, so I'm not going to show that. Anyway, the last one, we'll skip, we will not do activity 6 now, we will do this in class, but for activity 5, you're supposed to create a bash script that will continue to sum numbers entered by the user until the user enters -99 to quit. The sum of the numbers entered should be printed out. Use a while loop to do this. The last one. Okay, cp template and then r5.sh, vir5.sh, insert. Okay, here we need a number to read from the user. See, somewhere it says create a bash script that will continue to some numbers entered by the user. This is another way of saying that you need to echo and read. So before, okay, I will just create a variable here called number, which is what we get from the user, and initially it is 0, and the sum is also 0. Okay, then in the while loop, you have to check if the number that was entered by the user is not equal to -99, because here you quit when you stop looping. Looping meaning you stop asking the user to enter the numbers when the user enters -99. Okay, do and then done. Now in the loop, you have to echo. You have to tell the user, please enter the number. So enter a number or -99 to quit. Okay, and then you read and store it in num. Okay, then you have to check again if the number that was entered by the user is not equal to -99, please what's it called, please add it to the sum. Okay, how do you add it to the sum? You're supposed to write sum is equal to dollar the bracket, and then bracket again, dollar sum plus dollar num with the $2. This is how you add this. Remember this statement. If you want to add two numbers or multiply or divide, whatever operations you want to perform, you have to put dollar, two round brackets, and then write whatever you want to write there, and then two round brackets again. So that will calculate sum plus number, and it will add it to the sum. Okay, or I'm not sure if you can do it like that, but anyway, just do it like this. Okay, sum is equal to whatever calculation you're doing, you should put dollar and then two round brackets, perform your calculation within the brackets, and then close the two brackets, and then fi to finish the if statement, and finally print for the user the sum is sum. Okay, let's see if this is going to work. r5.sh 20 30 -99, that should give me 50. Okay, the sum is 50. There's an error on line 21. go back on line 21. I think it's this error. Insert, go back, run it again. 20, 96. Okay, so that's how you would solve this question. The only thing is, in the while loop, you're checking if the number is not equal to 99, because as soon as the number is 99, you were minus 99, you're supposed to stop looping. Then in the loop, you need to ask the user to enter a number, or they should enter minus 99 to quit. Then you read the number and you check if the number was not 99, only then add it to sum. If you don't do this check, what happens is the number minus 99 will also be added to this equation. And then the what's it called? The total will not be the correct answer. So again, you have to check in the loop. If it is not equal to minus 99, only then add it to sum. And then after the loop, you are supposed to print the sum. If you print the sum in the loop, what happens is it will keep printing the sum every time it loops. So that's incorrect. Okay, I think that's it. This question has functions, which we did not cover still. So I will, once we cover that in class, once we cover that topic, we can come back to this question. But for now, what I want you all to do is to finish Unit 8 activities, both selection and repetition. And if you have any questions, please email me, because I want you to finish this before next class, which is on Wednesday. And if you have any questions, we can also discuss it in the class time. So yeah, that's it from my end. If you have any questions, please let me know. I'm sorry this video was too long, but I had to just finish all the activities in one video, and then I'll make another video for the lab itself. I would recommend you keep practicing this as many times as you can. Only then you will become good at it. There is nothing in programming that in programming, if you want to become good at it, you have to practice it on your own. You have to figure out ways to do it differently. This is not the only answer. The answers that I'm giving you are not the only answers that are correct. There's thousands of other ways of doing these questions, and you're more than welcome to try and figure those out. That is one thing that will make you a good programmer if you're looking to become a programmer. So anyway, all the very best. Let me know if you have any questions. Have a wonderful day, evening, whatever, whenever you're watching this, and see you next time. Bye bye.